We are set to go.
All right. Well, we're actually more or less on schedule to the extent we have one. So on you get.
Good. Thank you very much. Challenge today was palindromic numbers. Numbers that are the same when read right to left, left to right, like 1, 2, 3, 2, 1. I have 5 participants. I believe one has dropped off. And so there are 3 components to your presentation. One is your approach, your idea. The second is your code. And the third is your result. Now, in the interest of time, abbreviate your discussion on the code because it's dense and it's probably difficult to follow. So please emphasize the approach you use to solve the problem and the results you came up with. And we'll be limited to about 8 to 9 minutes. And let's start off with Bob Armstrong.
Hey, Bill, would you mind if I participate? This is Dave Henderson.
Yes,
I didn't sign on.
yes, Dave. We'll add you. We'll add you at the end. Yes.
Thank you.
Okay. I'll go right to this. Is this visible?
Looks beautiful.
Okay. Yeah, one of the things that I should explain that the COSI is a vocabulary in-force that I'll say leapfrogs all the way to APL and essentially Lisp. Brad's talk was very interesting. And it's all in a programming notebook environment where if you have the cursor on any line, you tap F6, it does it. And one of the things about the APL level vocabulary is that really it's understandable concepts on ordered sets. I'll just put it that way. Anyway, really went through this yesterday, and one of the things that I'm hitting F6 now, and let me get some of this garbage out of my way on my screen. And okay. Doing this in decimal, anytime I hit a line like that, I'm hitting F6. Essentially, first I create the numbers from, well, that's an irritating little black thing at the top and messing around with it. Anyway, okay, iota goes and gives the first n integers and formats them. And so this is taking them, formatting, and then that gives, and then reversing these, and then concatenating them. We'll say this is applying reverse and then concatenation between each pair, and then this line I can go into deeper, but it's again reversing, creating, reversing, and adding the middle column. But let me jump down to here, where it concatenates all those 3 lists together, and this is a not terribly it's not a problem. I need to go and revisit that. And one of the things to go on from there, I take that, this is all done with characters, and this essentially reconnects them into a line and turns them back into integers. So this is a checks out that we all agree that there are 1,099 of them. Want to show this works in other bases too, and to go through this, one interesting line here is that oh, let me come down a couple more. Where am I? That's the first. This is the second. This is the third. And actually, I wanted to point out, I had 99 in here earlier, but on any base, 101 minus goes and makes that general for bases. And let me, oh, I did something. I don't know what I did. That's what happens when I go off script. So, okay, back to you.
Very good. And we did see the hex bases there on your right-hand column. Okay, next up is John Rybo.
Okay, so Bob, if you'll stop presenting.
Oh, where is that stupid thing? Oh,
you got
good.
it.
Yeah, good. And I'll mute.
And pick the one that I want and then put it up. Mine is in standard, basic, simple fourth. And I wanted to do it, or noticed that I could do it in all the bases. There's a symbol formula for or pattern to palindromes. And I found that I did it digit by digit. So I worked out first the single, double, and they each had the form where an odd number and an even number went just as deep. Here, the 3 and 4 digits both required 2 nestings to get them, and so on up. I found that I had to use unsigned numbers to get the full range, and just a bunch of nested do loops. So what I did was run it through Swiftforth. A safety thing, just do that. And what I've done is just pasting it in so that every line that's compiled, there's an extra OK on there, but went through and did the 3 deep, 4 deep. The first example in base 10 puts out the 1 digit prime palindromes 2, 3, 4, and 5. And then I went and added the code for doing 4 deep and did it just by saying binary run 1 to 8, and then printed the sum, the count, out in decimal, and there's all the binary 8-digit palindromes. That is the entirety of my approach, my results, and if there are questions, I'll answer. Otherwise, I'll put the link to this code. I'll put it in the chat. Any questions? Okay, Bill, back to you.
Very good. I love the code is very structured, and the investigations of various bases. Very interesting. Okay, next up is Philip Zambrod.
Hi, okay. So let's see if I can share my editor. There we go. Okay, I think in a sense, my approach is very similar. I generated this is basic G4 generated the digits from the outside to the inside, and did this recursively, and drove the recursion essentially by a set of tables, or yeah, and these tables are living here. Let me scroll down a little bit. Same effect as John just described. So the 1 and 2 and 3 and 4 and 5 and 6 digits all have the same recursion depth. And over a few code iterations, I found that with these tables here, you can actually see which digits are created by which iteration. So here you have just the single digit, same digit here, same first loop, and then from 3 digits on, the first iteration does the first and the last. The second iteration, second recursion does the middle one, etc., etc. And I'm just doing it with multiplication. So these digits in the tables are factors, and then per recursion, the corresponding recursion depth factor is multiplied in a do loop in the outermost from 1 to 9, so 10 exclusive, and all the inner ones from 0 to 10 exclusively. And I just realized that I probably forgot the 0, so this code actually doesn't print a 0, so I would have to add that. And initially, or somewhere in between, I would say this was all essentially one big function, and because I had to juggle 3 or 4 or 5 values on the stack, and ended up writing quite a lot of stack comments, then I broke it out into a few words. So a defining word here for the tables. This here is the recursive word, and then one that moves to prepare the next recursion, moves the pointer into the table one ahead. One that produces the loop limits, so takes care of changing from 1 to 9 to, or 1 to 10 to 0 to 10 after the first loop. And this final one, the word that prints and exits so breaks the recursion if all is done, marked in these tables by a factor of 0. And what I found is that it's very easy to extend this to more digits. The differences in base is just taken care of, that each loop goes to 10, and this doesn't matter whether this is 10 binary or hex or decimal or something else. It will do the right thing in any case. There are no other numbers here. And then actually going over the different digit widths, I just unrolled the loop and through the different tables as they were created into one word. And that's what I have.
I'd like to compliment you on the breadth of forth you're using. Create, does, and recursion, bringing all the tools forth. Are there any questions?
I May I make a comment?
Of course.
Please go ahead. Yes.
Okay. I think you guys are all thinking as fourth programmers. Okay. So Bill threw out a question and everybody's thinking, how can I solve this problem in full and write coding accordingly? But this problem, I think is a trivial one. Okay. You don't need a code to solve it because for a decimal 5-digit number for the to generate the correct number. The first digit, all 10 choices are good. The second digit, all 10 choices are good. The third digit, all 10 choices are good. And the fourth and fifth one are fixed. So you only have 10 to 10 to 10, 1,000 choices, and they are all good. Okay, so you don't need you don't need any code to solve this problem. Okay.
It's a little bit of field, but Dr. Ting indicates that only the last two digits are important, which is 10 times 10, which is 100. And it appears that over fixed ranges of palindromic numbers, there is 1% of the numbers are palindromic. So if you go from 1,000 to 10,000, 1% of the numbers will be palindromic. But let's not get lost on that. Let's get back to Brad Nelson. Your turn.
All right, let me go ahead and share my screen here. So having a new toy, I decided to use it. So I for my approach to this, I decided to use the Lispy list building words that I'd built up that I talked about earlier. So what I did is I created this word digits that takes a number and converts it into a list. And so it starts with a nil list and does a begin until, looping over, doing div mod, and then using this swap pair to append to the list. So for example, if you had 1776, what you get out is a list that if you print it, it consists of 1776. You sort of splay out each digit. And then using the other words that I built up, this becomes easy to figure out if something is a palindrome. So you can take you can take a number, convert it to digits, duplicate it, reverse it, and then see if it's equal. So you just check to see if it's a palindrome. And then this check can be used to generate the list of numbers in this range. Take this method and filter from that list, and you get out the ones that are palindromic. So you get, sort of the giant list. Now this is horrifically inefficient, right? You're building up a giant list of all the numbers in that range, and then building up, for each of them one by one, building up a list where you have only a single digit for each element, each element is one digit to check, but you get the whole set. But you can operate on them as a whole. So if you have that list of words, you can do things like measure the length and print it out, or you can go and average them and print it out. Last evening, Bill raised the question of could you figure out the ones that are both palindromes in hex and in decimal. So that's straightforward. And you can just take your number, duplicate it, switch to hex, check if it's a palindrome, swap that, and then switch to decimal and see if that's a palindrome. And if they both are, then this condition is true. And in the same way, you can then go over that entire range and filter out the ones that are palindromic in both bases. This is the decimal representation, and this is the hex representation. Not the most efficient method by any means, but using my new toy and generates lots of garbage. So it was a good stress test for it as well.
Brad, am I correct that Your entire solution was that first screen, which is about 12 lines of code.
Yes, this is it. I mean, it assumes that you have the garbage collector and the list building constructs and all of that. But for the core problem, yes, this is it.
That's fantastic. I don't understand it, but I am totally impressed. Are there any other questions?
This is a purely
Really
emotional-
nice, Brad. I like the conciseness, and I like the next screen of the very quick solution to the ones that are common to different bases. I'm sorry. Yeah, that is great. Thank you very much for all of this stuff.
This is a
Yes, I
rather
really like
emotional-
that testing of the multiple bases.
This is a rather emotional response, but my father's hobby in the last years of his life was chasing palindromic primes. And he always was trying to figure out whether there might be an infinite number of them. I've never been interested in going down that path, but he just loved it. It occupied his time for a lot. He would have loved everything you've done.
Righty. Well, back to you, Bill.
Very good. Really delightful. All right. I think Francois Logel, I think he left early, but is he still around by any chance, Francois? Yeah, earlier he had to say goodbye. Okay, finally, up is Dave Henderson.
All right, can you hear me?
Very good. Yes, Dave.
Okay, I'll share my screen here. Okay, so can you see my screen?
Yeah, you're on. It's very good.
Okay, so I took your challenge to do the 5-digit numbers from 0 to 99999. And so what I did was make an is palindromic test to look at a string of the 5 numbers, which I generate here using the picture formatting. And so I check the outer digits up here. And if those are equal, I check the inner digits. And return true or false on this is palindromic, and to determine whether to type out that string that I just generated. So I'll type it here, put in a little formatting so it doesn't go off the screen. And then at the bottom, I compute the percentage and do some formatting to put a decimal point in it. And I'll show I used VFX Forth to run it. I'll run it right here. And I get the series of numbers and a percentage down here, which turns out to be 1%, which I hope is correct. And fun little exercise, and trying to find a way to do it in the time that I have available. And anyway, I appreciate being able to present. Any questions?
Again, I love your approach of using things that are built into Forth already, like the number formatting. It's great to know and understand the tools that are built in.
Yeah, and it was, go ahead, to get it working. To get it working was, I had to learn a little bit more about the picture formatting, so that was good.
Dave, how does it deal with different bases?
I do not know. I had set some narrow restrictions on this to get it done.
Right.
Good question, though.
The picture formatting, you just set the base and you will take care of itself.
Oh, okay. Good to know.
The decimal and the hexadecimal, the numbers are the same, are treated the same way.
I'll have to try that. Any more questions? Thank you for allowing me to present.
Great. I'd like to thank all the presenters. I think you hit a new high water mark on clarity and brevity. We got the ideas and we didn't get bogged down. It was very, very good. I'm going to be doing a wrap-up presentation. Are there any other questions or comments before I delve into that? All right. Panel. All right, I am set to go. As by way of introduction, this is going to be a slightly extended presentation because I'm trying to build an educational component into these presentations. And so I see a lot of you graybeards here certainly know all of this material, but for newcomers, there'll be some programming techniques built in. So today, we've seen about 6 or 7 solutions to the palindromic problem. I have another approach similar to some. We're going to see a systematic approach to that solution. I'll do it in decimal hex, and then at the very end, we'll do it in both decimal and in hex. So top down, let's look at a problem statement. The problem today was very straightforward, which is over an integer range, display the palindromic numbers in columns. Well, if you pick that problem statement apart, look for keywords, and the keywords will translate into programming activities. So first there's a range, so that implies we have a do loop. It'll be done in integers, not floating point. The palindromes means a pattern detection, right to left, left to right. And finally, referring to columns means that we expect some kind of formatting in the output. So these are components that have to go into our solution. I do a D chart on this to get going. The D chart reads fairly logically. Top left, we set up the values and we set up a do loop range of numbers. Factor separates the digits. So if we have from 1 to 6 digits, they're separated out individually. Go through a case statement to figure out how many digits are present. Once we know the number of digits present, we can do a pattern test. And then finally, at the end is a conditional display the format. So each of these ends up being a 4th component in pseudocode. Now remember, as you approach one of these, start with your problem statement, find the key components, write the pseudocode. So we set up the variables and a column counter for formatting. Then over our range of numbers, we'll get each integer in turn. At this point, we use /mod to 6 times to divide our input number by the numeric base. At this point, the numeric base generally is 10, but it could be any other number. We then select the analysis on the quantity of digits, anywhere from 1 digit to 6. Then we do a comparison, which looks at the digits in each column, and if they match, then code to display that number, and finally handle the formatting. These are the words that are that result. They're very Forth-like in naming. We have a report program, which is the overall wrapper that does the entire project. We factor by our base. We assign through a case statement the number of digits. There are 6 programs called n-factor, or 6 components called n-factor, each one of which does a digit comparison. And finally, the report pulls it all back together again in formats. So let's look at how we would write the simplest beginnings to this. Just extracting the do loop, we would set up our values, we would do loop, and the code, 1 line of code, it's a do loop, get a number, print a number. So 1 line of code has got us on our way. Then if we add the conditional test at the end, when we actually get a palindromic number, the code expands in that point. So we still have our do loop, but then for each number I, we force a true condition, and then that's the if statement does the formatting. This puts us into columns for report. Again, we started our program now, and we've gotten about 20% of the program written in 4 lines of code. The next would be to add the pattern test. And then add factoring into digits. In this case, I've used values, more convenient for use, and the values are numeric bases, either 10 or 16. The divisor is an active base we're going to use at each for the conversion. And then housekeeping are the number of digits and the column counting. So there's only two pieces of code that are critical. The first one is taking our individual number and breaking it into 6 digits, factoring it in decimal form. So that code takes one number and gives us 6 stack values. We take those 6 stack values and then run through a case statement. If we only have 1 digit, which is the 0 case, every 1-digit case is palindromic. So in that case, the 6 drops our input values and we force a true because all single-digit numbers are palindromic. The case of 1 handles 2 digits, the next is 3, 4, 5, and 6 digits. At the very bottom is the drop 6 false, which is the default case, which should never execute. And finally, this handles the 5-digit case. There's actually 5 of them, digits 1 through 6 of them. And we just simply use the, from our 6 factors, if we do a 5-pick, 2-pick, that compares the end values. The 5-pick, 4-pick compares the center values, and they're combined together into one Boolean. So the next step after you're writing a program like this is you want to write some test words. You can test words individually on their own, or you can combine them together. So here I've generated, for a 5-digit test case, I've generated the word test 5. It does a CR return. The factors into 6 digits. The .s prints them for a quick check. And then the 5 factors examine them to see are they palindromic or not. And finally, we get a little report. If palindromic, you get a true, else we get a false. So down at the bottom is a quick little test. If we enter 1, 2, 3, 4, 5, and then test 5, we will see the 6 component numbers, 5, 4, 3, 2, 1, 0. Non-palindromic, so it'll be false. If we enter a 1, 2, 3, 2, 1 and do the test 5, we'll see, of course, it is palindromic and get a true. So these are sample test components that are done through our development process. And our result, as we've seen before, numbers from 1 to 999, the palindromic values. Here they're in hex. This is from 909 hex to FFFF. You can see the hex values. And here are from around number 100 to 100,000 or 200,000. We only see there are about 12 palindromic numbers, quite rare. So to summarize, we started out with a problem statement. We found keywords. We then did a flow diagram. And by breaking into components, at that point, the code almost writes itself. We can see the need at each step along the way. It's our attention is focused to one focal point at each level, which results in one word. As we know, we analyze from and design from the top down, and then finally do the word coding from the bottom up. And then very important is to plan the testing as a part of the design process as we go. And finally, we want to add comments for our code because at least I know I returned to a project a year later and the logic, my original logic may have been lost in the fog of time. So you really want to place comments in the code for your own personal benefit when you come back to the project. And do we have any questions or comments? Please come now. I see we're all in stunned silence. That is very good. And we are at or a little bit ahead of schedule, which is great. One final questions, any other questions or comments from anyone? Okay, back to Kevin. Oh, I'd like to thank all the presenters. Very innovative. I learned something every time we go through this. Thank you.
Okay, I don't see Dawn.
So it may be that he forgot about us. The meeting notices and other things that I sent all said third Saturday, and that's today. So do we have John Katsoulis, or however that's pronounced,
Everybody?
with us?
Now you
There
got
he
that
is.